In this video, we're going to be talking about Rolle's theorem and the mean value theorem. And both of these theorems have to deal with a piece of graph of a function. Not the complete graph, just a piece of graph. All right? And the endpoints are very critical for Rolle's theorem and the mean value theorem. And also, they're in the same video because one is really the other, but it's a special case. All right, so we're going to be looking at it. Let's go ahead and look at the objective for this video. Determine how many times Rolle's theorem or the mean value theorem applies to a function on a given graph. All right, find the value that satisfies Rolle's theorem and find the value that satisfies the mean value theorem. So let's go ahead and look at Rolle's theorem. Suppose that y is equal to f of x is continuous over the closed interval a, b. Now, what is it saying in that piece? In that piece, it's saying continuous means that there's no holes, right? No jumps, no asymptotes. Okay? That's what it's saying. So it's going to be continuous throughout. Over the closed interval a, b. Now, the brackets here means that a and b are included. They're not open. And differentiable at every point. What does differentiable mean? Differentiable means that there's a derivative at every single point. So this guy is going to eliminate the peaks, the cusps, the corners. Okay, so this guy right here eliminates the peaks, the cusps, and the corners. If f of a is equal to f of b, now what this right here is saying is that my endpoints have the same y value. Okay, then there's at least one number c between a and b, right, at which the slope will be 0. That's what Rolle's theorem said. Rolle's theorem said, hey, if I have a piece of graph and the y's are the same, you're guaranteed to have one point in between a and b that you're going to have a slope of 0. That's Rolle's theorem. All right, so in other words, given a continuous piece of graph that includes the endpoints, if the endpoints have the same y value, then there's at least one point on the graph that has 0 slope. Now, it says at least one, meaning that there could be more than one, but in this case, you're going to have at least one. Okay? So let's look at this piece of graph. And I have my endpoint here. That endpoint and that endpoint have the same y values. So the question is, how many times does Rolle's theorem apply? So what I'm going to do is I'm going to connect from here to here. Oops, that guy is a little bit off here. Oops, undo. Let me change it to my cursor. I don't know how to change it to the cursor. Nope, I can't do it. Let's just make the dot bigger. There you go. So how many times does Rolle's theorem apply? Well, right here I'm going to have a slope of 0. Right here I have a slope of 0. Right here I have a slope of 0. And right here I have a slope of 0. And right here I have a slope of 0. So Rolle's theorem actually applies 1, 2, 3, 4, 5. And that's it. That's how you actually end up doing Rolle's theorem. Okay? Now let's look at this one. How many times does Rolle's theorem apply? And some of you are going to say, hey, sir, I got it. The answer is 1, 2. And I'm going to say, I am sorry to tell you, Rolle's theorem, right here, does not apply to this piece of graph. Why? Because look at this endpoint and look at this endpoint. This one has an endpoint at 2 point something, while this one has the slope at point something. So they have different y's. So Rolle's theorem does not apply. Okay. Now we're going to be looking at that graph in a little bit in more detail. The question is, could you do Rolle's theorem? So let's pretend I gave you a function. Let's say I gave you y is equal to x squared. And I gave you the point -2 to 2. The interval from -2 to 2. Well, the very first thing that you're going to do is you're going to find the y coordinate. So I'm going to plug in my -2 here and my 2, and I'm going to try to find my y coordinates. So I take the -2 and I plug it in, and I'm going to end up with -2 squared, which is really 4. I take the 2 and plug it in, and I get 4. And what do I notice about my y values? They're the same. So Rolle's theorem is going to apply in this function. So what am I going to do? I'm just going to take the derivative y prime, which is 2x, and I'm going to set it equal to 0. And now what I'm going to do is I'm going to solve for my x coordinate. So I divide by 2, So at x equals 0, I'm going to have a slope of 0. So my slope is 0 at x equals 0. So if I had graphed that function, let me go ahead and graph that function here. If I graph that function, that's going to be y equals x squared is going to go like this. And here is 2, and here is negative 2, and here's my y value, and here's my y value. So if I was to have connected the endpoints, if I connect the endpoints, I'm going to have a slope of 0, and right there, I'm going to have a slope of 0. And some students might say, hey, sir, is it always in the middle? And no, it's not always in the middle, okay? So be careful with something like that. So let's look at this one here. And somebody said, wait a minute, sir. What if I connect my endpoints? All right? What if I connect my endpoints? That is not a slope of 0. That one's going to have a negative slope. My slope is going to be negative, right? So it's going to be negative. So let's go ahead and let's look at it in more in detail, okay? So on this one here, I am going to take my endpoint, and I'm going to take my endpoint and I'm going to connect it. And when I connected, the slope of the blue line is the slope of my endpoints. Now, what do I notice about this dot right here? I notice that at that dot, I have the same slope. If you notice the tangent and this secant line here, they're going to be parallel. Well, there's another dot right here. There's another dot that has the same slope. So somebody said, wait a minute. If Rolle's theorem, I'm going to have the same slope as the endpoints. Well, what if it's different and it's not 0? And that's how mean value came about. Okay? So let's look at it. How do I find the slope of my endpoints? Well, my slope of my endpoints, I can use algebra. Okay? This guy here, I'm going to call this guy. My first point is going to be, does it really matter if I call it A or f of A? Okay. I'm going to call this one A, f of A. I don't know where it is. I don't know where that dot is. So this here is going to be A, and this is going to be f of A. And this dot over here, this dot right here is I'm going to call it B, f of B. Okay. I don't know where it is. So this point here is going to be B, and this y value is going to be f of B. All right. So how do I find the point? How do I find the slope between this point and this point? Well, I'm going to use f of A minus f of B over A minus B. Now, some of you might say, hey, sir, can I use f of B minus f of A over B minus A? Yes, you can use that if you want. It doesn't matter which one of those you use. So that's the slope of my endpoint. Now, I just lost my cursor. All right, here we go. Now, what about the slope here? Well, we've been using calculus, and the slope here and the slope here, I can find the slope there. All I have to do is, using calculus, is I can find the derivative, right? So that means that my slope there, my slope here is going to be f prime of x. And my slope here is going to be f prime of x. So I have two dots where my slope is can be easily found using the derivative. So I'm just going to pick one of them, and I'm going to call that point, I'm going to call it C. Okay, so I'm just going to say, oh sir, my slope here is C. My x coordinate here is C. So what's my slope going to be? That my slope there is going to be f prime of C. So now, what I want is, I notice that my green line is parallel to my blue line, meaning that the slopes are the same. So if the slopes are the same, then the slope of the blue line, which is this guy, let me use the blue color here. The slope of the blue line is this one, and the slope of the green line is this one, and they have to be equal because they're parallel. Parallel lines have the same slope. And guess what? We just found out. This is the mean value theorem. So let's go ahead and look at the formal definition of the mean value theorem. Suppose that y equals f of x is continuous over the closed interval a and b. Wait a minute, that sounds very familiar. Sounds like Rolle's theorem. It's continuous, gets rid of the holes, the asymptotes, and the jumps. And this says that we're going to include the endpoints. Differentiable is going to get rid of the peaks, cusps, and corners, right? Then there's at least one point C. There's going to be a C between A and B. That means that there's going to be a C, at least one of them, where the slope at C is going to be the same as the slope of the endpoints. Golly, that sounds very familiar. If I had done Rolle's theorem, that means that what? F of A minus F of B, because they're the same, I'm going to end up really going to go F of A minus F of A, right? Which is, because remember, F of B and F of A are the same. Huh? That means I'm going to end up with 0 over A minus B, and that's going to give me 0. Okay? So, the mean value theorem versus the Rolle's theorem. Please understand, every single Rolle's theorem is the mean value theorem. It's a special case of the mean value theorem. Okay? So, all Rolle's theorem are mean value, but not all mean value are Rolle's theorem. That's what it says in this one slide. Okay? So now let's look at it. How many times does the mean value theorem apply? So let me try to see if I can try to connect the endpoint here. Oops, I missed it again. All right, so that's my slope there. So how many times am I going to have the same type of slope? Okay, so I'm going to find there's going to be one there, one there, one there, one there, and one there. So the answer is 1, 2, 3, 4, 5. So the mean value theorem applies 5 times on this piece of graph. Okay? It is not always going to be 5 times. The mean value theorem says that at least 1. For sure 1. And in this case, there was 5 of them. Okay? So now let's go ahead and work a problem out using an algebraic function. I'm going to be giving you a function, and I'm going to give you an interval from 0 to 1. So what is it that I need? I need the mean value theorem here. I like to tell my students to do the mean value theorem, and there's going to be the calculus way and the algebra way. So what's the calculus way? The calculus way is just going to be the derivative. So what's the derivative of that? 3x squared minus 2x. That's it. I'm finished. And on the algebra way, I'm going to need points. I need 2 points, and I don't have them. So I'm going to have to find them. So when x is 0, my y will be 0. When x is 1, my y will be 1 cubed minus 1 squared is going to be 0. So now what I'm going to do is I'm going to go 0 minus 0 over 1 minus 0. So now the calculus way is going to be 3x squared minus 2x has to equal to 0. So they both have an x in common, so I can factor out the x, and I'm going to be left with 3x minus 2 is equal to 0. Now, using the principal product of 0, if a times b is equal to 0, okay, and you're saying, what are you talking about, sir? Right here, this guy is a, and this guy is b. If a times b is equal to 0, then one of them has to be 0. So that means that x is equal to 0, or 3x minus 2 is equal to 0. So that means that 3x is going to equal to 2, divide by 3, divide by 3. That means that x is equal to 2/3. This and this are my possible 2 solutions. Now, let me ask you this. In order for it to do the mean value theorem, it's saying it has to be between. So my interval is from 0 to 1. And this guy here, he's an endpoint. So this guy does not satisfy my mean value theorem. This one is the one that satisfies it. So x equals 2/3 satisfies the mean value theorem. Okay? And that concludes my video.